You know, we're always searching for that perfect source of clean energy. Well, what if I told you there's a power source as predictable as the sunrise, but with the raw, incredible force of the entire ocean behind it? That's the promise of tidal energy, this constant, rhythmic pulse that could, in theory, power our entire world. But what's the catch?
I mean, harnessing that kind of energy seems like a total no-brainer in our quest for clean power. Unlike wind or solar, tidal energy is incredibly reliable. We know exactly when the tides will rise and fall. It's a predictable powerhouse. So you have to wonder, why isn't the whole world running on it? Well, that's exactly what we're here to figure out.
It sounds almost too good to be true, doesn't it? And that's usually the point where you have to start asking the hard questions. So that's where our investigation really begins. What are the hidden environmental costs of sinking these massive turbines into our coastal waters?
And the answer, at least for now, is a sea of unknowns. Seriously, because this technology is so new, scientists and engineers have found themselves with way more questions than answers about the long-term impacts of these underwater energy farms.
So let's go back to 2010. A group of experts, organized by NOAA, got together for a really important meeting. Their mission? Not to find all the answers, but to do something maybe even more important. To create a map of our own ignorance. To actually chart this vast sea of unknowns surrounding tidal energy. And that's a crucial first step if you want to do this right.
To make sense of it all, they started with a pretty simple idea: the environmental stressor. Just think of it as anything a tidal turbine does that could potentially mess with the local sea life. You know, from the constant hum of its blades all the way to a potential chemical leak.
And on the other side of that equation, you've got the environmental receptor. This is any part of the environment that might be affected by that stressor. We're talking about everything from fish and marine mammals to the physical seabed itself.
So, with this framework of stressors and receptors, the scientists really got to work. They started systematically mapping out all the potential ways that tidal energy could interact with the delicate marine ecosystem.
And what they came up with was fascinating. It wasn't just about the obvious danger of spinning blades. They considered everything. The sheer physical presence of these huge structures, the underwater noise, chemical leaks, the effect of literally pulling energy out of the ocean currents, and even the electromagnetic fields from the massive power cables.
So, to organize all this complex information and figure out the biggest areas of concern, they created these incredibly detailed risk matrices. Let's take a closer look at one to see exactly how they work.
All right, so here's the matrix for chemical effects. Red means high risk, green is low, pretty simple. But the real story here is in those little triangles. They represent scientific uncertainty. And as you can see, there are triangles almost everywhere. That's the takeaway. We just don't have the data yet.
And here's the real kicker. Scale changes everything. A single turbine might not do much harm at all, but a whole farm with hundreds of them? The report warns that the combined noise could actually be enough to throw off the migration patterns of fish and maybe even whales.
So this brings us to the verdict on tidal energy, at least based on what this group of experts concluded. And it's a finding that continues to shape the entire industry today.
The single biggest takeaway from the entire workshop? The incredibly high degree of scientific uncertainty, right across the board. The experts all agreed that for most of the potential impacts, we simply don't have enough real-world data to make solid predictions.
Which brings us to their main conclusion, and it's summed up perfectly in this quote from the report. Understanding of many environmental impacts can be achieved only through careful monitoring of pilot-scale deployments. In other words, you gotta walk before you can run.
So if we don't know all the risks, how do we move forward without causing some unintended harm? Well, the report lays out a very clear, very cautious path for responsible development. It's a straightforward three-step strategy, often called deploy and monitor. First, you deploy small pilot-scale projects. Second, you monitor the environmental effects incredibly closely. And third, you share that data openly so that everyone can learn from it to guide the future, larger projects. And this all translates into a clear set of recommendations. Focus our research on the biggest unknowns. Develop consistent monitoring rules so we can actually compare results. Be ready to adapt and change as we learn. And, maybe most importantly, share our findings with the world to speed up the learning process for everyone.
So here we are at the edge of a vast, untapped ocean of energy. The potential is immense, a true game changer for our planet. But the ocean is also a delicate, mysterious place.
So the real question isn't just can we harness its power, but should we? And if we do, are we willing to do the slow, careful work required to get it right?
Thanks for watching. Support BioVellum by liking, subscribing, and sharing. Let's explore the secrets of nature together.